Good morning, everybody. Thanks for joining us today. So today we're going to be taking a slightly different approach to our usual kind of AI webinars, and we're going to be talking more about kind of the open source of it all. So we're going to be focusing less on BrowserStack and more on what open source tooling is available and kind of the benefits, challenges of those. So if we can move to the next slide. So myself, I'm Gary B, and I'm the field CTO for BrowserStack. So I help our enterprise customers with automation, maturity, scalability, efficiencies, different things like that, all kind of tied into the BrowserStack ecosystem and beyond. And with me, I have Alex Rodionov, who is a tech lead and Ruby maintainer for Selenium. He also created a really cool AI testing tool called Alumnium, which he's going to talk about today, among other things. And Alex is going to be our main kind of driver today. I'm just here to facilitate. And if we go to the next slide. So just a few housekeeping items, the usual deal. Today's session will run for about 60 minutes. All of our participants will be muted to enable the speakers to talk without being interrupted. We will have 15 minutes for Q&A at the end. You can put your questions in via Q&A as well, and we'll kind of get to as many as we can at the end. For any we don't get to, we'll try and follow up after the session for those questions as well. The session is being recorded, and the recording will be made available to everybody who is attending now, and anybody who registered but couldn't attend will also be able to get that recording as well. And then we have the agenda. So it's a very simple agenda. We've split into two parts. We're going to talk about manual testing in different AI-assisted tools, and we're going to talk primarily about automated testing and the different tools that are available. And that's split into four buckets: the test generators, test runners, test libraries, and then we're going to talk about some of the challenges that these tools face and that they bring to the table. So without further ado, I'll pass you over to Alex and we'll get started.
All right. Thank you, Gary. Thank you, BrowserStack, for this amazing opportunity. I'm really excited to talk today. And yeah, the agenda is just we'll talk about a little bit about AI-assisted manual testing, and then we'll jump really deep into the landscape of open source solutions for test automation and talk about all these different approaches, which pros and cons they have, and which ones you could use to power your AI-powered testing. All right, so for manual testing, the open source landscape is not so great at this point. The situation is that there are a lot of different products that provide you with different solutions that use AI to help with manual testing. I think open source is kind of catching up at this point. There are no one solution that would allow you to do that. However, a lot of the things that the tool provide can be done right now manually through these kind of generic AI solutions or chatbots. We're all familiar with ChatGPT, Google Gemini, or Claude, and we can use them to do a lot of heavy lifting and a lot of assistance as we go through the manual testing process. As you know, LLMs are amazing at generating new tests. This is what they're generating new text. This is what they're created for. This is what their primary purpose is. So anything related to documentation, it works really well with LLMs. And an example that I personally often do is whenever I have to go through kind of documentation cycle for planning the testing, what do we test, what kind of the test plan we have, what test cases we end up with. LLMs can help a lot with this heavy lifting. So we could start with something like product page requirements. And let's say this is an internet shop. So we were talking about some product page and we have some requirements. How do we turn that into test plan, test cases, and how do we actually schedule all the manual testing we have to do? I think LLMs can help a lot with this. And you just pretty much start by giving the requirements and saying, try to create a test plan from this. And then you iterate, you review what the LLM provides you with. You work through, you maybe make some improvements, and then you get to a certain kind of a state where you have a test plan. And here, of course, it's pretty big, but here, for example, I've put just the test objectives that could potentially be part of the test plan. And every company has their own test plan formats. So you have to work with LLM to figure out how exactly to structure that. But then when you're happy with the initial version, you can dive deeper and you can use the same test plan, the same requirements, and try to draft the test cases from it. Put them in a table, put it in the format that you would expect, and then again, iterate over, maybe create more negative scenarios, maybe create something, rule out something that makes no sense for this particular logic. But the point is that LLMs excel at generating text. So you can work with the requirements, and then to test plan, and then to test case. Oh, you can do all of that to build the initial heavy lifting and scaffold the test plans and test cases. I think it works amazingly well for AIs, and pretty much any big generic purpose large language model excels at this, whether it's GPT or Claude or Gemini or Llama, whatever you feel comfortable with and whatever you like, they all are very good at that. And a couple of practical recommendations I have is to, first of all, start just by talking to LLM and trying to tell it what to do. And then at some point, it will pretty much give you maybe test plan in a different format, and you have to start giving it examples. So if you have examples in your documentation wiki or something where you have requirements, test plans, test cases, how do you format that? How do you structure it? Just put all that, give it as an examples. Every year, the window context for LLMs get bigger and bigger. So just recently we had 1 million context window in Gemini, and that was amazing. Now we have 10 million in Llama 4, which is 10 times bigger. So fitting all these examples is possible, and it definitely makes LLM produce more accurate results. The second recommendation I would have is use the thinking model. So every provider now has this reasoning models like DeepSeek R1 or OpenAI has O1 and O3. There is, I think, Gemini thinking model, and Anthropic has Claude 3.7. So these thinking models, and if you're not familiar with them, they kind of think through before responding to your request, and it massively improves their accuracy, and they hallucinate less, they provide more meaningful results. So use those. Start with something that works fine, and then if you hit some roadblock, try switching to thinking models. They're very good. At a certain point, if nothing really works, start engineering your prompts. Prompt engineering is still the king when we work with LLMs. And I've listed a couple of resources here, which I personally found very useful. There is a promptingguide.ai, which is a collection of prompt engineering resources. So you can learn about things like zero shot, few shot, prompting, chain of thought. These are all very, very useful when working with large language models. And then if you are using these thinking models, there is a wonderful free course on deeplearning.ai about using O1 from OpenAI and making sure you prompt it correctly, because the reality is that the thinking models are supposed to be prompted slightly differently. For example, you don't tell them what to do, but you rather give them examples. And if you do that properly, they're very accurate and they provide amazing results. And
Do you want me to take this one?
yeah, sure.
So yeah, so just because we're talking about manual testing, and really just to keep the lights on at BrowserStack, I have to bring up a BrowserStack product in some way. So I'm going to talk about two specific products that are leveraging AI tooling at the moment, right? So what Alex has described about, feeding it in test cases and requirements and things is exactly what we want to do. I think what we're trying to do with our products are provide a way for you to do that in an organized fashion and to give you meaningful outputs and aesthetically pleasing outputs in the form of reports as well. So our test case management platform is akin to Zephyr, Qtest, TestRail, all the other competitors in the marketplace. And with our AI features, you can do a lot of things. You can create test cases. You can use the existing test cases that you have to create low-code automation tests, which I'll come to in a moment. You can generate these test cases from a simple prompt, from a requirements document, or using our plugin directly inside Jira, using the content of the Jira ticket itself, which is quite powerful in its own way. And another thing you can do, another thing it does is it actually takes the context of all the other test cases in the folder that you're currently in to flesh out the detail of the test and make sure that there's the correct information is being there. So if you give it a vague prompt and there's no other context there, it's not going to give you anything meaningful back. But if you give it something slightly vague, but there's other test cases in the repository, then you get something more meaningful back from it. And all of these features are available as part of the subscription to test case management. There's no specific AI pricing model behind it. And then on the next slide, we have our low-code automation tool, which is exactly what it sounds like. You create low-code automation via record and playback. But using AI, you can also create low-code automation tests from a prompt. You can basically, in the middle of creating a low-code test, you can put in a prompt to say, do these following steps to fill in this form or whatever it might be. You can also create the low-code tests, as I've mentioned previously, from test cases in test case management. And that's where the kind of the power comes in. And it's something that I've been referring to in my conversations recently as the triforce of efficiency. So the Jira, test case management, and low-code automation. So you can start with a Jira ticket, generate your test cases, and then generate low-code automation tests from it. So something that would take a manual tester 60 minutes, let's say, can be done in 5 to 10, which is a 6x saving and is really good. Now, is it perfect? No, I don't think any AI tool is, but it is very, very good and very, very powerful, and there's minimal tinkering involved in getting it to work. So I think it's a very powerful tool, and it's something that we hope to see more people using, and also something that will be growing because we've invested heavily in our AI tooling, so we'll be seeing a lot more from it in the future. And again, it's not a paid thing, it's part of the low-code automation tool. And I'm going to pass it back to Alex now to talk about automation. And I'm going to launch a poll question here as well. So just if you can give your answers to that while we're going on as well.
All right. Yeah, as I mentioned, especially for test case management and kind of working with through requirements, test plans, and test cases, I think open source is catching up, and there are a lot of great products like BrowserStack that allow just to do all this tedious back and forth conversation pretty automatically. So that's amazing. All right, let's dive a little bit into automated testing, because I think here we have way more interesting projects from open source community. And when we're talking about AI automated testing, I think we can pretty much group things into 4 different buckets. We start by just generic kind of assistance. You write your tests and you want to make it faster, so you can use generic purpose auto-completions and IDs like Copilot, Cursor, Windsurf, like things that would just allow you to iterate faster and just kind of provide auto-completion and changes to the source code at the speed of your thought, or even anticipating your thought. I think these are all very powerful, but they're not really, they're not specifically designed for test automation, right? They are useful. I use them daily, and it's a massive boost in productivity. But if we talk about test automation specifically, we have actually very concrete projects that allow you to iterate faster and deliver faster test automation. And the way I kind of think of them is there are test generators, there are test runners, and test libraries. And I put them in this order from something that is easy to use, easy to start with. And test generators, from my opinion, are the easiest ones. And then you got to test libraries, which are the most advanced, but also require most of the knowledge and kind of more demanding from a test engineer. So let's just kind of go through these 3 different buckets and look at specific projects, open source projects that exist now, how they use, how they work, how you can use them. And throughout this conversation, because I want to keep things practical, we'll be testing a calculator. So something that you all are familiar with. There is a web-based calculator, and we're going to be writing a test for 2 + 2 = 4. And I'll actually show how all this can be done with all these different tools. So test generators. The way test generators work is that you are supposed to write tests for it in some format that it expects. And typically, most of the tools use Cucumber and Gherkin format. So you are still to write this test in Cucumber format. And then when you run this test generator, you give it your test and you give it the link to the application you're going to test. It starts the browser, and then it reads your test, and it tries to use AI to generate the code for the test that could potentially satisfy your test scenario. So it does this in a loop, kind of trying to do things until the test either passes or fails. And then when it's done, it dumps all this generated test code into a file. So it puts it somewhere in your source code so you can review it, you can read it, you can refactor it, you can do whatever you want with it. You can run it, of course, make sure that it still works. And then as soon as you're happy with it, you can just commit it to the repository. An example project that I think is one of the best test generators is called Lavag. I have a QR code here in the bottom right to the GitHub repository, so you could check it out real quick if you're interested. And as I said, the way it works is that we start by creating a test scenario in Cucumber format. So we have a calculator scenario for addition, and then we say I'm on the home page and I perform 2 + 2 =, this is the action we're performing, and then we have some assertion that the calculator value should be 4. So that's all the code that we've written. Then we run this test generator and we give it the URL to our web calculator, and we give it the path to our test. And it starts the browser, it starts connecting to AI, and then kind of does its magic, going back and forth, figuring out which buttons to click. And in the very end, you can see that it says finish generating test in 50 seconds. And you can actually go ahead and inspect this Python code that it was generated. And the generated code would look somewhat like this. So for example, for the step where we perform the action to sum 2 + 2, the underlying Selenium code that this tool generates looks like this, where we click some buttons in particular order with some expected conditions. And then in the step where we assert that the value is 4, it looks somewhat like this, where we take some input from the page and we take its value and we assert that it is 4. So this is a regular Selenium test written with Python, so we can just run it as PyTest. And you can see that it passes, it is very fast, it takes just a second. And I think most of the time is spent just starting the browser. But at this point, this tool generated us a working Selenium test that you can commit to repository, add to CI, and kind of start using from now on. Or you can refactor it and kind of get to a state where you want. So the test generators work great for new projects. If you are just starting, there are no tests, you're not even sure where to start, you can start using the test generator pretty easily, right? So just write a couple of tests, use this tool to generate, see if it's still working, if it's still passing, then you can commit and work and iterate over this test later. I think one of the greatest advantages is you can actually see what's happening. You can see what's generated, inspect the code, whether you like it or not. But you at this point, it's just the code. There's no AI communication. It's just there, plain text. You can change it however you want, and you can inspect it. Once the tests are generated, they're fast. They're just regular Selenium tests. There is nothing AI there. And because you generate once, it's pretty cheap, right? So you run this tool, it uses AI, you pay for this initial generation, but after that, you don't have to pay for anything, right? And the cons are kind of related to the general idea, right? Because this tool expects tests in a certain format. If you have existing tests, you may be written in a different test runner with a different infrastructure. You might be using Selenium Grid. You can't easily integrate things one into another, right? This tool will start the browser for you, and if you have the code to start the browser in some specific conditions, you can't just easily connect one to another. And you might not be happy to write tests in a certain format. So this is kind of the limitation that it puts on you. It does have certain expectations in how you write your tests. Maybe you don't want to use Cucumber, but everyone is happy with Cucumber, right? But even if that's all fine by you, another big problem with test generators is that once generated, it's just a regular Selenium test, which has all the same problems that any other test would have, meaning when the UI changes, this test will start to fail, right? There is maybe it can be created in a sort of flaky, with a flaky code that will not always work. But the point is that there is no self-healing or something in this test generator solution that would allow you to withstand UI changes as the test, as the application evolves.
So I think, yeah, to that point, Alex, and this is trying to make this as organic as possible. You mentioned the no auto test generation piece there. One of the other features that we have at the moment within BrowserStack for Selenium tests specifically is the idea of AI self-healing. So if you have tests that are running in the BrowserStack ecosystem on our Automate platform, you're running those tests and they're consistently passing, and then all of a sudden a web developer goes in and changes a locator, for example. It's just something has changed somewhere. Our AI self-healing, it can be enabled with a single line in the configuration file. You can turn it on, turn it off. And then if it finds something that has changed compared to the previous test, so it gathers context, it will then look for a relevant locator and self-heal that for you, so your test doesn't fail for no reason. And I think that's a useful tool that saves people a lot of time, saves a lot of effort. And you'll see it from the screenshot that it tells you what selector it couldn't find and what the heal selector was, so that you can then go and update that in your code very easily. It doesn't update it for you. We're not quite there yet, but it does tell you what the locator is, so you can go and put it in yourself. And there's a QR code here you can use to go to the documentation on that to see more information about that if you're interested in it. And back to you, Alex.
That's pretty cool. And as soon as it starts making these changes directly in the test, I think it will be massive improvement for sure.
I'm hoping that happens soon. Yeah.
All right. So we talked a bit about test generators. Now let's talk about something different, which I call test runners. And the way they work, these kind of tools in this bucket work, is that just like with test generator, they do expect you to write tests in some format. They understand. So I call these test runners because we have JUnit, we have Cucumber. They are all test runners, and they expect tests in a certain format. These tools do the same thing. So once you write this test, you don't generate anything. You just commit them to your repository, and then you can run them locally. You can run them on CI. And actually, during the execution of the test, the tool will be starting the browser, will be taking the information from the browser, sending it to AI, and kind of doing that, trying to figure out what actually needs to happen in the browser to make the test pass or fail. And one of the most popular tools in this bucket is called short test. Again, there is a QR code to the GitHub repository. It's written in TypeScript, and as the name implies, the short tests stand for very short tests. So the way you write these tests is you just load the library, and then you write your test as a single line of code, a single string. So here I've written the same calculator test as just 2 + 2 = 4. And this is everything this test needs to understand that I would actually need to be clicking some buttons and asserting that the final result is 4. And then the test runner will also provide the CLI library that you use to run this test. So again, it would start the browser, and it will be taking actually the screenshots from the browser along with some extra information and sending it to AI provider, and kind of doing this in a loop, in a sort of agentic flow, if you wish, until either your test is passing or it's failing. And this particular project called Short Test, it's actually using a thing called computer use from Anthropic. So if you are not familiar with what it is, I think OpenAI has now a thing called Operator, which is similar product. But the idea is a kind of special LLM that is trained specifically to accept the images of your computer browser or the whole screen, and then understanding what kind of buttons these have, how you can click on things, and where the cursor is. And then you tell it, I want to do 2 plus 2. And it tells you you have to move cursor, 10 pixels to the left, 20 pixels to the bottom. And then you press left mouse button, and then you kind of do it in a loop. So it literally tells you how to move the mouse, what kind of keys to press. And it all works through the screenshots. And it's very powerful. It's like, you can see that it's very easy to start with this kind of tests. So just like with test runners, it's super easy to start for new projects. When you don't have any tests, you can just add the library and start writing a few lines of code to kick off your testing suite. It's really easy to use. And because the test execution is powered by AI, it is resilient to UI changes, right? So if we change locators, nothing will break because it uses screenshots and it's know that, okay, this still looks like a button too, so I would still need to click it. And as long as it's visible and as long as it looks like a button, that will work. So these are great things. Not so great things about test runners is that, just like generators, you can't really integrate them into existing tests, right? So they expect certain format, they expect to handle the start in the browser, in particular resolution, and they will do all of that for you. But if you already have logic for creating test user, starting the browser, you can't easily integrate and reuse this logic. Also, things that might not be very obvious from when you start playing with it is that it's actually going to be very expensive and very slow. Different test runners implement different solutions, but Short Test uses computer use from Anthropic, as I said, and computer use is very expensive. And because it works by taking the screenshot, sending it to Anthropic, it's kind of takes a while to take the screenshot, send it over the internet. Then the LLM has to process this whole screenshot and then respond that you have to, let's say, move the mouse at a certain coordinate. And then you have, again, to take screenshots, and it goes over and over. And you've seen here that, running this test takes 1 minute. And in terms of cost, running this test would actually cost around 15 cents. So if you have hundreds of tests and you run it on CI, you can easily get to a point where you have a huge 5 figures bill, and you won't be happy about that. So keep that in mind when you start with test runners. Okay, and last bucket of solutions for test automation are test libraries. And from my point of view, these are the most advanced. These are the ones that allow you the greatest control over what's happening, but also requires most from you in order to be successful. So the test libraries, the way they work is you just add them like any other library, like you add Selenium or Playwright or anything else. You just install it through the package manager of your programming language. You write your tests as you would be writing them without this tool. Maybe you use Cucumber, maybe you use PyTest, maybe you use some other test runner. It doesn't really matter. So you just keep writing your tests, and then somewhere within the test, you just call this library API, right? Like you call Selenium API, you would call this tool. And then during the test execution, as soon as you call this API, the tool will be taking information from the browser and sending it to AI and trying to kind of do its magic to interact with our system under test. So the project, the test library that I'd like to talk about is called Aluminum, which is the project I work on. And again, have a QR code here for the GitHub repository. But what Aluminum is, it's essentially a library written in Python, which provides a high-level API for Selenium or Playwright. And it allows you to do actions on the page, get data from the page, and then check for some verifications. Because it's just a library, the one that you install like Selenium, you can integrate them into existing tests, and it doesn't force you into pretty much any kind of commitment in this space. You can start rewriting some tests. You can maybe use it in part of your test, or maybe write a new test with it. And you can analyze how well it behaves, how fast it is, how much do you spend on it, and kind of if you're not happy, you just can roll back, right? So there is a very gradual migration path because it's just a library rather than a full-featured runner or generator. Aluminum supports all major AI providers, Anthropic, Google, OpenAI, whatever you are comfortable and happy to use. You can use any of those. You can also use it with open models like Llama or DeepSeek. It also works with them. So maybe if you're privacy concerned, you can self-deploy these models in your infrastructure and use it. And it works on the kind of low-tier models. So every provider has the cheapest, fastest, not super smart, but also not really dumb models, such as GPT-4o Mini or Gemini Flash. So they all provide this kind of special models, and Aluminum works with them specifically because it tries to make sure it's affordable, right? And the same 2+2 test written with Aluminum would look somewhat like this. So we have the test is written with PyTest, but it could have been written with any other test runner. There is no restriction. And then we just open the URL through Selenium, just with regular Selenium API. And then we use this action command to do something on the page. So we tell Aluminum do 2+2 equals, and it will be talking to a browser, figuring out what actually needs to happen to achieve this goal. And then we're going to be taking the calculator value from the page and asserting that it equals 4. And that's it. You run it as any other test. So we use PyTest, so we run it as PyTest. If it was written with Unitest or Cucumber, we would run it with their test runners. And you can see the test is executing, and actually during execution, it does this AI communication and it's passing within 8 seconds, which is compared to other solutions which are using screenshots is much faster. So the pros for using test libraries such as Aluminum is that they are easily integrated into existing tests. So you can just install them and start using them because they are the actual usage happens during the test execution. Again, it also is resilient to UI changes. So if the selector changes or something, they're not supposed to fail. Different test libraries have different support for AI models. Aluminum supports all of them, and it is extremely hard to make the same tool work consistently for different AI models. So we take a lot of effort to make that happen. It's also fast because we use caching and other things. Of course, it's not as fast as just regular Selenium test. There is an extra layer of communication here with AI, but it's fast enough. And it's cheap because, again, different libraries provide different solutions, but Aluminum is specifically designed for the cheapest possible models. And because of that, I think when I was measuring this test for 2 + 2 = 4, it was costing less than 1 cent, maybe like 1/10 of a cent. And that's significantly cheaper than what we were having with computer use, for example, where it was 15 cents per test. We run thousands of tests on CI in GitHub repository, and I think we pay about $20 per month for all the providers, meaning Google, OpenAI, Anthropic, and everything else. So the cons for test libraries is like any other library, you're supposed to learn it, what kind of API it has, how you need to configure this library to serve best for your particular web application. You still have to write the code. So there's a lot of idea that we go to low code, no code. Test libraries are not like that. You still have to write your code. You still have to write your test, and you still need to call this API explicitly. And you kind of have to be precise because you use these actions to do something, check something. You have to be precise where you have to call which and how exactly you want to structure your instructions, right? So it kind of takes an iteration and learning curve to use these tools, just like any other library you would use in programming. And yeah, maybe now it's time to do a short demo. I wanted to show Aluminum with a couple of scenarios. So this calculator that we talked before, if we kind of extend it, we have it over here. We just use the Selenium to navigate. And then we use this Aluminum do 2 + 2 = get the calculator result from the page, assert that it equals 4. We do the same for 5 - 3. We do the same for multiplication, maybe 3 multiplied by 4 = 12. And then division, 8 divided by 2 = 4. And what happens is if you go to actually underline the code for the configuration of the test, so when we use driver, it's just the regular Selenium WebDriver Chrome. And Aluminum, the way you use it is you just load it, and then you pass an access to the driver object, and then from this point you can use it, and it will be working with the browser. So we can run these tests to kind of show you what happens internally. So this is our app. You can see that the tool now starts interacting with UI. It does this by talking to LLM. You can see it's passing, and maybe if you want to make it broken, we can change multiplication. Let's say 3 multiplied by 10. So now it probably be as 30, and our test is failing, as you would expect, with an assertion error. A slightly more complex example I wanted to show is the BrowserStack demo website. It's an internet shop which has some products. So we're going to open it with Selenium, and then we're going to use Aluminum to add iPhone 12 Pro Max and then iPhone 12 mini to the shopping cart. We're going to ask Aluminum to get the titles of the products that are currently in the shopping cart. They will be visible on the screen, and we're going to assert that these are actually what we just added. We're going to proceed to the checkout from the shopping cart, at which point we will see something like a login screen, and we're going to log in with credentials that are actually provided there on the screen, username and password. We're going to finish the login, and then we'll be actually at the checkout page. We're going to get some information from the order, like what's the price of one of the products, what's the price of other, what's the total amount. we will finally see some kind of form where we have to provide first name, last name, address, state, and postal code in order to complete our order. We'll do that, and there will be a message about it. The order was placed successfully. You can now, you will receive something, and we will just use a new check to verify that it's there. So let's try to run it. So this is our BStack demo. We've added some products. We did some assertions. Now we have to log in. We take some prices here and asserted it, fill in the form, submitting it, and this is our successful message. So the test is passing in 16 seconds. Let's again intentionally break it. Let's say we're actually expecting the order is placed message not to be shown. And let's rerun this test. So now it should fail in the end, and it should provide some kind of meaningful explanation why we get an assertion error. So again, fill in the fields, submit in, and we have a test failure. We can see this is an assertion error. So it says that there is a message says in your order has been successfully placed. So our statement is false, and that's why we have an assertion error. Okay, so that's it for the demo. But if you are interested into using any kind of AI-powered tools for test automation, you have to keep in mind a few things. So one of the first thing is LLMs are probabilistic machines. They're non-deterministic by nature. You can tweak some knobs. You can say set temperature to 0. You can change top P, top K, and kind of try to get it as deterministic as possible, but it will never be 100%. And that is a challenge by itself, right? So we want our tests to be very stable. We don't want another source of flakiness, and LLMs are another source of flakiness. So if you want to use this kind of flexible approach to testing, where you don't have to write a lot of code, you have to embrace that sometimes the test is going to fail, and you have to plan for how do you handle this flakiness. And Aluminum takes a lot of effort to solve that for you, for example, but it's not 100% done. And even if LLMs are behaving similarly, the AI providers are actually not so stable yet. The reality is that all this OpenAI, Azure, just yesterday we had an outage in Microsoft Azure OpenAI service, and for a few hours the CI test suite was failing because it was just timing out. So the AI provider's infrastructure is not as stable as you might be used to at this point. So you have to keep that in mind. And the tools, all the tools that I've demonstrated, they work wonderfully well for simple scenarios, and they tend to work worse the more complex web applications we're testing. So the BrowserStack demo is a simple internet shop. If you try to do the same on Amazon, you're going to run into a lot of problems. The tests will be slower, they might be more brittle, they might be less precise as you would expect them to be. But in any event, just overall, all AI-powered solutions kind of tend to work worse as the complexity of the system and the test grows. You have to understand that because we add another layer of indirection here, there is LLMs. LLMs are not super fast, right? So they take time to produce new tokens. So I don't think AI tests could be ever faster than just writing this plain Selenium code yourself. And different solutions take different approaches to solve this. In Aluminum, we have caching. And when the caches are fully used, the performance is similar to what you would have with Selenium because we cache the communication between the LLM. But you have to keep in mind that if you want to use the solutions, the performance will be worse. And of course, you have to understand that there will be extra costs. So they could be small, it could be large, depending on which approach and which tool you use. But there will be extra costs for infrastructure, because either you have to pay for AI providers or you have to self-host the LLM and pay for hardware. So keep that in mind as you go. I think I have a lot of hope, and I personally spend a lot of time developing the solutions for test automation with AI. There are a lot of challenges that we're still yet to solve, but I definitely can see this working out. And maybe in a few years, we'll have most of our tests written and kind of guided by you, but the actual execution will be happening with AI. And at this point, we can jump. I'll pass it to Gary.
Yeah, perfect. And there's a new poll gone up there as well for people to answer. And so, yeah, thanks, Alex. I think that was, it just shows what that open source is and always will be the greatest adopters of these kinds of things. And it's great to see that they're embracing AI in testing and really kind of, bringing it. And Alumnium is one of those tools. And honestly, I'm very impressed by it. I have a couple of questions myself, but I'm going to go with the audience questions first. So I'm going to start at the top. So the first question we have is, in AI test generation examples, so you have the locators, they're generic XPath locators, which are automatically generated by the browser. So those are, as we all know, they're generally poorly maintainable. So are there tools which can generate like better locators, like CSS selectors, IDs, test ID, test data ID attributes, things like that? Or are we just looking at XPath at the moment because of the nature of the way the AI works?
I don't think it's the nature of the AI works. The example with Lavag is, I think, it's just because Lavag, the way it works, it's implemented with XPath. I think the tool allows you to kind of tweak what the actual prompt looks like. So you might be able to tweak it and tell AI, if there is a test ID, use test ID. If there is a class, use class. But I'm unaware of any other tool that would work out of the box and provide better locators.
Okay. So our next question is from Tomash, and he's asking if, like, will AI-based code generators have problems with the DOM size of a web app? So he's the example of like using a JavaScript framework will cause the front-end code to be very bloated. And even when you remove the pure JavaScript from the DOM, you still get inputs with hundreds of thousands of tokens. So is that a concern? Is it something you've come across? Like, what are your thoughts on that?
Yes, and the reality is that none of the tools use DOM, right? Like clear DOM. So there are different approaches. Some tools like Lavag, there is other tools that are not specifically for testing, like Stagehand and Browser Use, which are generic browser agents. The way they work is they would try to find interactable elements like buttons, text fields. They would try to just list them out, and they will use this instead of pure DOM. So all this thrown away. Alumnium internally uses accessibility tree, which is way more compact. Again, it provides information on what you can see on the screen and how you can interact with it without classes, IDs, or anything else. So none of the tools really use DOM right away. Some other tools use screenshots, as I mentioned. And even then, even with all that, you still get to a point where you, let's say, go to Amazon search page, and you have so many information that you can't send it. The context window exceeds. And the way this is being overcome right now is by just chunking context. So you take, let's say, what is visible on the screen, and you send it to LLM and you say, is it possible to use it? No. And then you scroll down, and then you kind of take the next chunk and you send it. So yeah, that's kind of the approach. Nobody uses DOM directly. Everyone tries to filter out all the noise. Great news is that the context windows grow. We have 10 million with Llama 4 now, which I have no idea how it actually works, but it sounds amazing. I'm yet to try it. But yeah, I think over time, even as the context window will grow, things will be even easier.
Okay, great. So Dimitro, I hope I'm getting that name right. If I'm not, I apologize. Is asking how expensive is short test? And I kind of want to piggyback off that because that was one of my questions as well. Like for things like short test and Alumnium, what's the pricing model essentially? Like how is it priced? Is it like an AWS model where you give it your credit card and then you basically pay for whatever you use, or how does it work? Just to kind of piggyback off that.
So all these open source solutions, they're not self-hosted, because they're not like cloud solutions. You have to set up your Anthropic account or OpenAI account. You have to create an API key there, and you just give this key when you run it. And then the pricing, you pay to AI providers. So you don't pay to Short Test or Illumio, you pay to OpenAI and Anthropic. But how expensive is going to be different. So Short Test is the most expensive one because computer use from Anthropic this is what you pay for, is expensive. So these calculator tests, just one run of the test costs around 15 cents. You can extrapolate that. If you have 10 tests, that will be $1.50, 100 tests, 15. You can kind of scale it. And Alumnium is on the other scale, being the cheapest one. The same test with Alumnium, you pay for, let's say, OpenAI, it's going to be, I think it was 1/10 of a cent for a single test. So as I said, we run it on CI for 1,000 of tests, and we pay about $20 per month. And you can actually use it for free because Google has free plan for Gemini, and you can use Alumnium with Google to kind of experiment. It has some limits in terms of how many requests you can send to Google, but you can get it for free. We use it on CI for free from Google. So yeah, you can start with that, and then you can see how far it takes you. Yeah, so short tests, 15 cents per test, quite expensive from my point of view.
Very much so. Yeah, and just as a quick aside on the Alumnium side of things, I really love the do get check syntax, and I sincerely hope that becomes this generation's given when then, because I feel like it works really well and it describes how the flow of a test works really well. So it really kind of really spoke to me when I saw it. So I hope we see more of that in other frameworks. So Diana has a question now, and this actually is one that I'm particularly interested in as well because I have a background in game testing myself. So Diana says that she runs into issues when creating automated tests because she works on games. So the clicks are different per level every time. So do you think it's still possible to use automation in those scenarios where like it's never going to be consistent? Every time is going to be something different happening.
This is a very hard question. I've never really tested the games. To be honest, I'm not even sure how exactly the software testing for games. Do you have selectors there? Do you have anything to locate elements? If not, and you're operating on the screenshots, then yes, you can definitely use this. You can use things like short test. They work on screenshots. You can use operator from OpenAI. You can use different. There are quite a number of tools that are based on screenshots. There are even self-hosted LLMs, such as I think Microsoft OmniPass, which allows you to give screenshot and it will draw what elements there and kind of give you the coordinates. And then you can take this result and actually click yourself. So I think it would be possible, but again, maybe the caveat here is that you have to be very, very fast in the game, because by the time you get response from LLM, maybe everything is already changed on the screen. So I think it's going to be challenging, but I think it would still be possible.
It's interesting. I'm showing my age a little bit, but the last time I worked on games testing was when I worked at Microsoft Game Studio in 2007. So the industry's moved along a lot since then. It was all very manual back then. So it's always interesting to see what we're doing with automation in games. but it is, I agree, a very tricky area to do that in. So this is actually another question that I had as well that Chirant has asked, which is Alumnium compatible with custom Selenium frameworks as well?
Yes and no. So if there is a custom Selenium framework that lets you take give you access to Selenium WebDriver instance behind it, you can just pass it to Alumnium and it will work. But automatic conversion between, let's say, some framework to Selenium, there is no such thing yet. If you're interested in support for a particular framework, please go ahead to our GitHub repository and raise an issue for that, and we'll add it.
Perfect. And then Cyprian had a question. Do you have recommendations for tools very similar to Alumnium, but for native mobile applications?
So we actually had I was presenting Alumnium at the Selenium Conf just last month, and we had a conversation with Appium team with how possibilities to use Alumnium for it. And it seems like it would be possible, and it's relatively easy to add support for native mobile apps. So we have an issue on GitHub to track that. But as of today, the only tool I'm aware of is there is in Espresso software testing tool, there is something that allows you to kind of have similar approach, and you just instruct it what to check, what to do, and it will work. Give it a shot. Espresso has it if you use it. And again, on the Selenium conference, there was a presentation about some AI selectors for Appium. I don't know if they are released in open source yet, but you can probably find it on the Selenium Conf website. So that's the two things I'm aware of.
Okay, perfect. And then we have a question here. What are your thoughts on the reliability of the results received from these test runs? So if a traditional automated test runs, you assume that it validated the test condition correctly, but if we run AI-powered tests, can we rest assured knowing that it didn't skip any steps or provide false positives or negatives?
So my take on that is, if you can't assert something without AI, do that. And if you've seen if you were looking at how Alumnium works, you just ask it to give some information from the page, but you actually assert inside your test. So you don't just give everything to AI. And then if AI responds with something that makes no sense, maybe it's not on the page, maybe it decided that it looks different, then your test would still fail. So by making sure that you don't do everything purely with AI, you actually go to very robust tests. So if some steps are being skipped, then your assertion later will fail. So the test would still fail. And then you have to kind of debug and understand what actually happened. But they're pretty robust from that perspective. And I've never really run into false positive results, more often into false negatives than the other way.
So we are coming up on time. We've got 2 minutes left, so I'm going to try and get to as many of these questions as we can. So we'll do a bit of a blitz. So does Alumnium do what it does without any previous knowledge of the target site? So does it just replace the writing of keywords with AI, basically?
Yes, there is no specific prior knowledge that is required, but it also has, if there is something that no one can possibly know how to do on your website, maybe some domain specific, Alumnium also has an API where you tell it, where basically you teach it what can be done on your website with specific terminology, and you just tell it, in order to, let's imagine, complete a task, you have to click a checkbox near this task. So you give it some like this high-level generic explanation, and then it learns it from there.
Great. And I'm going to do one final question because we need to finish up, but will Alumnium be used for other programming languages in the future, or is it purely for Python and that's how it will stay?
It will not. It will add support for JavaScript, Java, Ruby. We are working on that. This is on the roadmap for Alumnium 1.
That's great to hear, because I think the more visibility it has, the better. So for anybody whose question we didn't get to, we're going to endeavor to try and answer them after the fact. So follow up by email. We have your attendee emails and stuff, so we'll try and follow up as many as we can. So yeah, so thank you to everybody who attended, and a special thank you to Alex. That was, for me, sitting here taking it all in. It was a really interesting session, and I love aluminum. I'm going to be using it myself a little bit going forward as well. And thank you for taking the time to talk to people today. And yeah, and thanks everybody for coming.
Thank you, everyone. I really enjoyed that. Thank you.